nations in the global power struggle are waking up to a brutal truth. Real dominance isn't measured by just the latest aircraft, but by the ability to stay one step ahead of any threat. With tensions soaring, especially as China, Russia, and the United States sharpen their military edges, innovation becomes the deciding factor. The SR-72 Darkstar, unveiled at the Aerospace Air Show, stands as a beacon of future warfare capabilities. How does this stealthy new spy plane tilt the scales of power in the world? And more crucially, how will it impact China's relentless military ascent? The stakes have never been higher. Join us as we dive into the Darkstar's potential to reshape aerial reconnaissance and alter global defense strategies. At the Aerospace Air Show, the SR-72 Darkstar emerged as the main attraction. This new pilotless craft combines remarkable speed with advanced technology and promises to transform defense strategies worldwide. Remote-controlled flying machines, known as drones or aerial systems, operate without human occupants. Military forces developed them in the 1900s for missions too monotonous, hazardous, or contaminated for human aviators. By the 2000s, these robotic flyers had become essential tactical assets. The Darkstar represents the latest evolution in this technology. The aircraft's debut has alarmed Chinese defense specialists, who now face the challenge of countering a surveillance platform that can penetrate their most protected airspace. As aerial reconnaissance systems continue to advance, the balance of global surveillance capabilities shifts accordingly. The Lockheed Martin SR-72, often called Son of Blackbird or Darkstar, is an American hypersonic concept for intelligence, surveillance, and reconnaissance that Lockheed Martin privately proposed in 2013 as a successor to the retired Lockheed SR-71 Blackbird. In 2018, company executives said an SR-72 test vehicle could fly by 2025 and start service in the 2030s. When the United States Air Force lost a remarkable intelligence-gathering platform, this led to an interesting shift in military aviation thinking. While the industry initially focused on developing stealthy aircraft that could evade radar detection, a compelling counterargument emerged. As adversaries developed increasingly sophisticated ways to detect stealth aircraft, some experts proposed a bold alternative. Pure speed might be more effective than stealth for penetrating defended airspace. This perspective challenged conventional wisdom and sparked a fresh debate about the future of reconnaissance aircraft. Early rumors about the SR-72 started popping up around 2007. People were saying Lockheed Martin had something big in the works, an airplane that could fly 6 times faster than sound. To put that in perspective, while the old SR-71 was incredibly fast, this new plane would double that speed, hitting around 4,000 miles per hour. At first, these were just rumors, but Lockheed Martin teamed up with Aerojet Rocketdyne back in 2006 to create the engine for this next-generation aircraft. When a project for another aircraft was canceled in 2008, they took the special jet engine technology from it and used it for the SR-72. They wanted an engine that could work at all speeds, from sitting still to flying faster than anyone had gone before. For the new SR-72, engineers created an ingenious hybrid propulsion system. The aircraft uses 2 engines working together through a single inlet and exhaust. At takeoff and lower speeds, it relies on conventional jet engines to build momentum. Once the aircraft reaches high velocities, it switches to scramjet technology, which thrives in supersonic environments. This dual-system approach solves the long-standing challenge of efficient acceleration across all speed ranges, from standstill on the runway to hypersonic flight at more than 5 times the speed of sound. The seamless transition between propulsion methods represents a breakthrough in aerospace engineering that could revolutionize both military and civilian aviation. When a plane flies 5 times faster than sound, it gets so hot it could melt normal metal frames. To solve this problem, engineers looked at using special materials that mix carbon, ceramic, and metals. These are not new materials. They have been used before in long-range missiles, and the space shuttle is now retired. These materials can handle extreme heat without melting or breaking apart. On the 1st of November 2013, a piece about Lockheed Martin Skunk Works' SR-72 project appeared in Aviation Week in Space Technology. The news drew so much interest that Aviation Week servers could not handle the traffic. The company revealed plans to build a demonstration aircraft that could be flown with or without a pilot. This test aircraft would be 60 feet long, roughly the size of a Lockheed Martin F-22 Raptor, powered by one full-scale engine, and would fly for several minutes at Mach 6. They aimed to have it ready by 2018 for flight testing, which would follow the schedule for the hypersonic high-speed strike weapon. General Mark Welsh, who led the Air Force, spoke on November 13, 2013, about his interest in planes that fly extremely fast. He explained that these speedy aircraft would give enemies less time to react when the Air Force takes action. Welsh believed hypersonic technology would create a significant advantage in future conflicts. The general noted that such high-speed capabilities would allow forces to strike quickly and decisively, potentially changing how military operations are planned and executed. By late 2013, the Air Force rejected funding for the SR-72 project. Money was tight, so they chose Northrop Grumman's RQ-180 stealth drone instead. This alternative was more affordable and simpler to manufacture. The military selected this particular drone for its ability to gather critical intelligence in hostile territories where enemy defenses pose significant threats. The RQ-180 was designed specifically to operate in contested airspace, collecting valuable data while maintaining a low observable profile to avoid detection. In December 2014, the National Aeronautics and Space Administration hired Lockheed Martin to see if they could build the SR-72's engine using today's jet technology. They paid about $892,000 for this study. In May 2015, people reported that SR-72 would gather intelligence and attack targets, but nobody said what weapons it would carry. This makes sense because current weapons probably would not work well on a plane flying 6 times the speed of sound, up to 80,000 feet high, that needs hundreds of miles to turn around. They'd likely need to create brand new sensors and weapons just for these extreme speeds. In March 2016, Lockheed Martin's CEO Hewson claimed they were close to a breakthrough that would let their SR-72 reach 6 times the speed of sound. She said they could build a test aircraft the size of an F-22 fighter for less than $1 billion. Back in the year 2017, Lockheed Martin made a bold announcement. The legendary SR-72 was finally coming. This hypersonic aircraft would hit speeds above Mach 6, that's over 4,500 miles per hour, and be ready in the early 2020s. In a moment of surprising candor, Vice President Rob Weiss acknowledged what many already knew. The company had been dangling the hypersonic carrot for 2 decades with little to show for it. "It's always been just around the corner," he admitted. But this time was different, Weiss insisted. The technology had matured, and with DARPA's partnership, they were finally ready to put this breakthrough speed machine in military hands. In 2018, another Lockheed executive, Jack O'Banion, credited new manufacturing techniques for the breakthrough. He claimed 3D printing and better computer models made the plane possible, saying they could not have built it just 5 years earlier. The new technology allowed the team to build cooling systems directly into the engines, which was a crucial advancement. In February, Lockheed Martin's story took a dramatic turn when Aeronautics Vice President Orlando Carvalho finally admitted that despite years of ambitious promises and flashy announcements, not a single SR-72 aircraft had been constructed or tested. The uncomfortable reality behind their hypersonic program became clear as Carvalho revealed that their research was primarily being channeled into weapons development rather than the revolutionary aircraft they had been promoting so enthusiastically to the public and military stakeholders. Throughout his carefully worded statements, observers noticed Carvalho deliberately shifting terminology away from specific references to the SR-72 in favor of the much more ambiguous phrase, reusable vehicle, a linguistic sleight of hand that gave the company significantly more flexibility as their technological aspirations evolved. This unexpected confession from such a high-ranking executive effectively demolished any remaining credibility in their previous bold claims about delivering a functional Mach 6 aircraft by the early 2020s, leaving many aerospace experts and military planners questioning whether the promised breakthrough in hypersonic flight would ever materialize. Later that year, on November 2018, Lockheed Martin announced plans for an SR-72 prototype to fly by 2025. They also mentioned the aircraft would carry hypersonic missiles. If all goes according to plan, the SR-72 might enter service sometime in the 2030s. Before the SR-72, there was the SR-71 Blackbird, the fastest aircraft ever built. This incredible spy plane could fly at over 3 times the speed of sound, leaving everything else in its dust. Born in Lockheed's secretive skunk works during the 1960s, the Blackbird was not just fast, it was untouchable. The genius behind it was engineer Kelly Johnson, who took the earlier A-12 design and made it longer to carry more fuel and accommodate 2 crew members instead of 1. When the Air Force unveiled the sleek black beast in July 1964, jaws dropped. It looked like it came straight from the future. By 1966, it was already zooming over hostile territory, gathering intelligence from heights and speeds that made it impossible to catch. Locals in Okinawa, Japan nicknamed it the Habu after a dangerous snake fitting for an aircraft that slithered through the sky faster than any missile could reach it. It flew at Mach 3.2 in 85,000 feet during missions, which let it escape or outrun threats. If radar picked up a missile launch, pilots would simply speed up to get away. The plane carried special equipment for spying missions, signal detectors, radar, and a camera. These aircraft needed so much preparation that each one typically flew just once a week. Out of the 32 planes built, 12 crashed due to accidents, but none were ever shot down by enemies. In 1974, the SR-71 broke the record for the fastest flight between London and New York. By 1976, it became the fastest air-breathing crewed aircraft, taking the title from its predecessor, the Lockheed YF-12. The Blackbird still holds all 3 world records today. The Air Force retired the SR-71 in 1989, mostly for political reasons. A few planes were briefly brought back before being retired again in 1998. NASA was the last to use the Blackbird for research until finally retiring it in 1999. Since then, spy satellites and drones have taken over its role. The Darkstar concept brings to mind the long-rumored Aurora project. Aviation enthusiasts and defense watchers have speculated since the 1980s about Aurora as a secret hypersonic replacement for the SR-71 Blackbird. Though the Pentagon never officially confirmed Aurora's existence, unusual atmospheric phenomena and sonic booms reported in the 1990s fueled theories about classified hypersonic test flights. Some analysts now wonder if the SR-72 represents the public evolution of technologies potentially developed under the Aurora program, or if lessons learned from earlier classified hypersonic research inform the current design. Aurora is supposedly a secret American spy plane from the mid-1980s, but there is no real proof it ever existed or flew, and many consider it just a myth. The United States government has always denied building such an aircraft. Aviation experts looked into it and concluded that claims about Aurora are based on guesswork or indirect evidence, so there is little reason to doubt what the government says. Ben Rich, who once ran Lockheed's secret Skunk Works division, explained in his 1994 book that Aurora was just a code name a Pentagon colonel randomly assigned to funding for the B-2 bomber competition. Somehow this name leaked to the media. However, in 2006, aviation expert Bill Sweetman, who has tracked secret projects for years, said after researching it for years, he believes Aurora is probably being developed, helped by recent technology advances that have finally caught up with the original vision from decades ago. The Aurora mystery began with a simple slip-up in 1985. Sharp-eyed reporters at the Los Angeles Times and Aviation Week caught something they were not supposed to see: the word Aurora mysteriously appearing in the public United States budget. This was not just any line item. The documents showed a massive $455 million earmarked for some kind of secret aircraft production coming in 1987. The government had not meant to reveal this black project. This accidental disclosure sparked decades of speculation about what might be hiding in America's classified hangars: a hypersonic spy plane that could leave the SR-71 Blackbird in its dust. Aviation Week said Project Aurora was not just one plane, but a collection of unusual aircraft. They claim funding grew to $2.3 billion in fiscal 1987, based on a procurement document they obtained. Later in his 1994 book, Ben Rich, who used to run Lockheed's Secret Skunk Works division, explained that Aurora was simply the budget code name for the competition that eventually produced the B-2 Spirit stealth bomber. By the mid-1990s, people reported seeing strange aircraft over California and the United Kingdom. These reports included unusual contrail shapes, sonic booms, and other phenomena that suggested the United States had built such an aircraft. While none of these sightings were ever officially connected to any specific program or aircraft, people often use the name Aurora to describe whatever they thought they were seeing. Starting in mid to late 1991, a pattern of unusual supersonic compression waves echoed across Southern California. These were not random events. They were captured by United States Geological Survey sensors designed to track earthquakes. What made these booms interesting? They didn't match the acoustic signature of the massive space shuttle. They seemed to come from something smaller. Adding to the mystery, records showed neither the space shuttle nor NASA SR-71B aircraft were flying on the days these booms occurred. This led aviation experts to a startling theory: the Black Star. Military watchers believed this would give the United States the ability to deploy satellites or conduct reconnaissance missions with almost no warning. The strange sonic booms, unusual funding gaps, and glimpses of triangular craft all seem to point to Black Star's existence, though the Pentagon has never confirmed it. In March 2006, Aviation Week and Space Technology magazine reported that the United States had been operating a secret spaceplane program called Black Star since the early 1990s, a revelation that shocked the aerospace community. According to the report, after the Challenger disaster in 1986, U.S. intelligence agencies needed a backup plan for putting spy satellites into orbit, and Black Star was supposedly their answer, providing a flexible alternative to conventional rocket launches. The revelation became even more intriguing when sources suggested the Air Force's own Space Command knew nothing about the program, indicating Black Star wasn't a military operation, but rather a system managed by an intelligence agency like the National Reconnaissance Office. The Black Star system reportedly used two specialized vehicles, a larger carrier aircraft that would take off from a conventional runway, carrying a smaller space plane, and once at high altitude, the spaceplane would separate and rocket into orbit, complete its classified mission, and then glide back to Earth without detection. Despite numerous sightings by credible witnesses and detailed reporting from a respected aviation publication, the government has never confirmed Black Star's existence, allowing it to remain one of the most persistent and fascinating mysteries in modern aerospace history. Aviation Week described Black Star as a clever two-stage system for reaching orbit, not just a single spacecraft. The first component was the SR-3, a large delta-winged aircraft similar to the B-70 Valkyrie bomber. This massive aerodynamic mothership was designed for exceptional speed, building on concepts Boeing had patented in the 1980s. Beneath the SR-3 sat the real game-changer, the XOV, also known as the Experimental Orbital Vehicle. This compact spaceplane was nestled between two engine clusters, with each cluster housing 2 or 3 powerful engines. This clever arrangement created an integrated system where the smaller craft could leverage the larger vehicle's capabilities. The concept was elegant in its simplicity. The SR-3 would ascend to approximately 100,000 feet before releasing the XOV. Once free, this compact vehicle, resembling the earlier X-20 Dinosaur project, would ignite its rockets and accelerate into orbit. This approach, if implemented, would have addressed numerous challenges associated with conventional space launches, providing the flexibility and reusability that SpaceX would later pioneer decades after Black Star's rumored development. Once released from its mothership, the XOV would fire up its rocket motors, likely aerospike engines similar to those on the Lockheed Martin X-33. This little space plane could do both suborbital hops and full orbital missions. One Aviation Week source claimed it could reach an orbit 300 miles above Earth, depending on what it was carrying and the mission plan. After completing its mission, the XOV would glide back through the atmosphere and land on a normal runway. just like a plane. The whole system, a jet-powered mothership carrying a rocket-powered spaceplane, was not entirely new. It shared some similarities with the civilian Tier 1 system in NASA's X-15 aircraft. But Blackstar could go much faster, enough to reach orbit. If real, this capability would have given the United States military or intelligence agencies a way to put satellites in orbit or conduct space missions without anyone knowing, which was a perfect tool for the post-Cold War era. Thanks for watching. While you are still here, click on the link on your screen to check out another of our videos. See you there.